Lesson 3-11, Equations, focusing on repeating decimals as rational numbers. Now remember, rational numbers can be written as fractions. So what we're going to do today in this video is show how you can take a repeating decimal and rename it as a fraction. So how are we going to do that? So steps to write a repeating decimal as fractions. We're going to start with writing an equation, x equaling whatever the repeating decimal is. And then we're going to multiply both sides of the equal sign by a power of 10 so that it matches the number of repeated decimal places in the repeating decimal. So that means if it's one decimal place that's being repeated, it would be multiplied by 10. If two decimal places are being repeated, you multiply it by 100. Three decimal places, that would be multiplying by 1,000 and so forth. After you do that, you're going to subtract the original equation from the new equivalent equation that we just wrote. And then we're going to solve for x and write the reduced fraction. So let's take a look at an example. Here, we're going to have x equaling, and then we have our repeating decimals. So this is 0.216 repeated. And what we want to do is multiply this whole thing. And because there's 3 digits being repeated, I want to multiply it by 1,000. So that means I have 1,000 x equaling 1,000 times 0.216 repeating would be 216 point, and then we'll say 216 because it's going to keep repeating the 216 there. Now what we want to do right now is take this original equation and subtract it from here. So that's minus 1x equaling 0.216. And the reason why we want to do that is because now that gets rid of the repeated parts. So now we got 999x equaling 216. Now to get x by itself, I'm just going to divide by 999. And now we have x equaling 216 divided by 999. Now I can reduce that. And to save some time, we're just going to do that on our calculator here. So if I take 216 divided by 999, here you can see the repeated decimal here. But if I hit math, option 1, I get 8/37. So now how did I get 8/37? Well, if I take 216 and divide that by 8, that gives me 27. So that means what we ended up doing here is dividing this by 27 over 27. And that gives us an answer of 8/37. So 8/37 is the same as that repeating decimal. Next one, we have x equaling 0.7 with the 7 repeating. Because it's only one digit being repeated, I multiply by 10. So we have 10x equaling 7.7 repeating. And I take this equation and I'm going to subtract. And this is going to give us 9x equaling 7. To get x by itself, just divide by 9. And x is going to equal 7/9. Next, we want to write this as a fraction. So we have x equaling 0.87 with the 87 repeating. Since there's 2 decimal places, I multiply this by 100, and I have 100x equaling 87.87. Subtract this here, so I subtract 1x equaling 0.87. That's going to give us 99x equaling 87. Divide that by 99. And x is going to equal, I'm going to divide this by 3/3. And if I do that on the calculator, 87 divided by 3 gives us 29. 99 divided by 3 is 33. So our answer would be 29/33. Next I have x equaling a negative 0.135 with the negative of the 135 being repeated. I'm going to multiply this by 1,000. So that gives us 1,000 x equaling a negative 135.135. So then I'm going to put this equation underneath. So we'd have minus 1x equaling, if I'm subtracting a negative 0.135, that's really meaning I'm adding 0.135. So that's going to give us 999x equaling, this will give us a negative 135. Divide this by 999. And then on our calculator, got negative 135 divided by 999. Hit math, enter. That's going to give us negative 5/37. Next, these are steps to write repeating decimals as fractions where the repeated digits are not immediately after the decimal point. So the first step is going to be the same. You're still going to write the equation x equals the repeating decimal, but the second step is a little bit different. So here you're going to multiply both sides by the equal sign by a power of 10 that the decimal point is just to the left of the repeating digits. Then we're going to multiply both sides of the equal sign by a power of 10 that matches the number of digits being repeated. And then we're going to subtract the original equation from the new equivalent equation and then solve for x and write the reduced fraction. So this is the only step that's going to be slightly different. So let's take a look at an example to make that more clear. So here we want to write 0.192 with a 92 being repeated. So we're going to start off with x equaling 0.192 with the 92 being repeated. Now I need the decimal point to be just to the left of the decimal point of the repeating digits. So I need this to be after the 1. So to do that, I'm going to multiply that by 10. So this is going to be 10x equaling 1.92. And then from this point, the 92 is being repeated, so I'm going to multiply that by 100 because 2 digits are being repeated. So our new equivalent equation is going to be 100 times 10x is 1000x equaling 192. And then from there, we are going to subtract the original equation. And just keep in mind that this is going to be 92 because the 92 is being repeated. So we're going to be subtracting the original problem from that, which the original is going to be this problem right here. So this is going to be the original. So we're going to be subtracting 10x equaling, so subtracting 1.92. So again, we just want to get rid of the repeated part. So this is going to give us 990x equaling 191. Now to get x by itself, divide by 990 on both sides. And x is going to equal, and we're going to grab our calculator. We have 191 divided by 990, and that's going to give us a repeating decimal here. So let's hit our math button, hit enter. So that's 191 over 90. So that would be the reduced fraction. So 191 over 990. Next, here we want to move the decimal point one to the right. So right now I had x equaling 0.5406 with the 406 repeating. I'm going to have to multiply this by 10. So our original equation is now going to be 10x equaling 5.406. Now I got to multiply this by 1,000 to get rid of the repeated part. So that's going to give us 10,000 x equaling 5,406.406. And then we're going to subtract the original. So 10x equaling minus the 5.406. When I do that, that gives us 9,990 x equaling 5,401. To get x by itself, divide by 9,990 on both sides. And then we'll grab our calculator. So 5,406 divided by 9,990. And we'll have to, let me check something here. I see the problem. I had 5,406. It should be 5,401 divided by 9,990. So 5,401 divided by 9,990. That gives you the repeating decimals. So if I hit math, enter, so that would be our reduced fraction. And our last ones here. Here we have x equaling 0.048 with the 8 repeating. So that means I'm going to have to multiply this by 100 because there's 2 digits that's not being repeated. So that'd be 100x equaling 4.8 with the 8 repeating. And then I'm going to multiply this by 10 because there's only 1 digit being repeated. So I have 1,000x equaling 48.8. And I'm going to subtract the original, which was 100x equaling 4.8. If I subtract both of those, that gives me 900x equaling 44. Divide everything by 900. And on our calculator, let's do 44 divided by 900. And we're going to hit math, option 1. That's 11 2/25. And our last one here, we got x equaling 3.274 with the 74 being repeated. We're going to have to multiply that by 10. So we have 10x equaling 32.74 with the 74 being repeated. Now I'm going to have to multiply this by 100 to get rid of the decimal. So that would be 1,000x equaling 3,274.74 and subtract the original, which is 10x equaling 32.74. This is going to give us 990x equaling 3,204.74. 42. Divide everything by 990. And on our calculator, we're going to have 3,242 divided by 990 and change that to a fraction. And we would get an improper fraction here. So in reduced form, since this is an improper, we have it as an improper fraction, so this would give us 1,621. All over 495. Or you can write it as a mixed number, which would be 5 and 136 over 495. But I would probably keep it as an improper fraction, and that would be in lowest terms. So that is our lesson on changing repeated decimals into fractions.